Let us see sketch of TE and TM modes in the cross sectional fields. So, this is our topic today. And myself, Dr. V. Vijayasree Bulshetty, Associate Professor, Department of Electronics and Communication. So, how we are going to sketch the TE modes and TM modes in their cross sectional fields. So, at the end of this lecture, the student will be able to sketch the TE modes and TM modes for different values of Mn, because generally the TE or TM is represented for Mn, TMN and TMMN. So, for the different values of M and N, how we are going to draw the fields. So, first let us see for TE modes how we are going to draw the cross sectional fields. So, TE mode means we are going to say the transverse electric mode. That means always if you take the rectangular waveguide, always the electric field is perpendicular to the direction of propagation. So, suppose if the wave is going to propagate in this direction, electric field is perpendicular, that means it is normal. So, electric field is always represented with a standing arrows. So, this is the representation of the electric field. So, how this electric field is going to vary for different values of M and N. Okay. So, in the last session we have seen TE10 is the dominant mode. So, we start from here. So, how we can draw the field patterns for the TE10? Here M is equal to 1 and N is equal to 0. Simply for a rectangular waveguide to draw the field patterns, we take the front face of the rectangular waveguide just like a box, rectangular box, and in this always M corresponds to the dimension A and N corresponds to the dimension B. That means this is the broader dimension A. So, M variations we can see on the dimension A and this dimension is B. So, N variations we can see on the dimension B. Okay. And here it is going to say there is one variation onto A and 0 variations onto B. That means there is no variations onto the B and there is only one variation onto A. So, we can draw the electric field like a standing arrows towards only one direction. Okay. So, this is going to say that there is no field variation and all the electric fields or lines of force is going to represent, it is plotting to the only one direction, single direction, univariation, single variation as M is equal to 1. And there are no variations towards N side, that is onto the dimension B, because N is 0. Okay. For example, if you take TE 1, 2, that means M is 1 and N is 2. Okay. So, for this we draw the rectangular waveguide. This is A and this is B and there is one variation onto M, that is onto A. So, we represent that variation. And there are two variations onto B. So, this is one variation, two variations we have to show. So, this is one polarity and this is another polarity. So, there are two directions here. So, we have two variations onto B and there is one variation onto A. Okay. So, this is going to say that the number of variations onto the broader dimensions A and B. For example, if you take TE two, 3, that means 2 variations onto A and 3 variations onto B. So, we can show that, suppose if it is a rectangular waveguide, 2 variations we have to show. So, this is one variation and this is one variation, 2 variations and 3 variations onto B. So, 1, 2, 3 half wave variations. Okay. So, all these are the half wave variations. So, this is going to, as we are going to consider about the transverse electric modes. So, we are drawing the field cross sections using the electrical lines. So, always electric line, as we have seen that it is going to represent that it is perpendicular to the direction of propagation. So, we always represent the electric line with a line, arrowed line carrying the electric field, and generally the magnetic field we represent with a disc, okay, magnetic lines of force. So, we will see that in the next slide. So, now let us see the field cross section for the TM modes, how we are going to. Right. If you see the TM modes, we need the magnetic field, that means how the magnetic field is distributed. For example, if you are seeing the rectangular waveguide like this, okay. So, the magnetic field is distributed to the parallel to the plane of propagation, as this is the propagating plane. So, the magnetic field is parallel to the plane of propagation like this, the magnetic field, and electric field is perpendicular to the plane of propagation, representing like this. So, this is going to represent the magnetic field and it is going to represent the electric field. So, here as we are discussing for the transverse modes of TM mode propagation, so we see how this magnetic field is going to distribute for the different modes of M and N in the TM mode of propagation. For example, first we start from the dominant mode. So, TM11 is the dominant mode. In this, as we are taking the front side face, this is the front surface, and while seeing the disc position from the front face, we simply represent it like a dot, because as it is parallel to the plane of propagation, it is simply represented or simply seen like a dot. So, here we are saying that M11, TM11, that means M is 1 and N is 1. Here whatever it may be, either TE or TM mode, this is the broader dimension of the rectangular waveguide and this is the narrow dimension of the rectangular waveguide. This is A and this is B. And for this, if suppose we are saying like this, that means A is 1 and onto the A there is one variation, and on to the B there is only one variation. That means on to A we can draw a single line, and on to the B we draw a single line, and wherever there is lines of intersection we represent with a dot. So, this is the TM mode of propagation. Magnetic lines of force is represented as a disc. So, here we are representing this is the TM11 dominant mode. TM11 mode of propagation in the fields we can represent like this. Okay. Now, if we go for like say TM23, that means 2 variations onto the M and 3 variations onto the N. That means 2 variations onto the dimension A and 3 variations onto the dimension B. Okay. So, let us draw the rectangular waveguide, and this is A, and this is B. So, we need 2 variations onto A, that means we draw 2 lines onto A, and 3 variations onto B. So, we draw the 3 lines. No need to represent with arrow because we are not concentrating on the electric lines of force, we just want their intersection points. So, what are the intersection points we are having? Right. So, these are the intersection points. So, here it forms a disc, this is second one, and this forms another disc, right. So, this is the field pattern for the TM23 mode. Okay. So, first draw the number of variations onto A and draw the number of variations onto B, and wherever these lines are intersected represent them with a dot, because magnetic field is represented by the dot and electric field is always represented by the arrow. Right. So, coming to the summary, that we can draw the TE modes and TM modes for different values of M and N in the respective cross sectional fields. So, we have seen the TE modes and TM modes, either it is electric modes E or M, we are going to represent them in terms of arrows or in terms of dots. Okay.